Geometry students to the homework help video, page 590, numbers 1 through 26. Let's jump right into this and get started. Here we go. Numbers 1 through 4, the directions say to state whether the solid is a polyhedron or not. So here we go. Let's take a look at number 1. Now remember, all of the faces have to be polygons, okay? If they're not a polygon, then it's not a polyhedron. Well, every face, like here's the front face, it's a rectangle. Here's the left side over here, it's a rectangle. Here's the right side over here, it's a rectangle. Here's the top, it's a triangle. Here's the bottom, it's a triangle. All of those shapes are polygons. So yes, we have a polyhedron. Okay? Number 2, no, we do not have a polyhedron. Look at the top face. The top face is a circle. A circle is not a polyhedron. Also, look at this whole side right here. This whole side is round. I mean, the entire side is round. Then also the bottom face is round. Guys, a polygon. A polygon, as we learned earlier this year, is either convex or concave, and it has all straight lines like this. That's a polygon. This is a polygon, okay? But circular sides, like a circle, they're not polygons. Thus, this cannot be a polyhedron because every single face on a solid must be a polygon if the solid is going to be a polyhedron. Number 3. It looks pretty good at first, but look at this. Look at this right here. The straight line, but this is curved. Straight line, this is curved. So the front face and the back face are not polygons. Also, look at this side. This is a rectangle right here, no problem. This is a rectangle right here, no problem. But this side right here goes over, then it's curved. Comes over, then it's curved. So we do not have all polygons. So we do not have a polyhedron. Alright? Number 4. Okay, yes, this is a polyhedron. The front face is a hexagon. The front face is a hexagon, okay? 1, 2, 3, 4, 5, 6. The back face is a hexagon. 1, 2, 3, 4, 5, 6. All of these faces over here are rectangles. All of these faces are rectangles. Every single one. So every single face on this solid is a polygon. So we know we have a polyhedron. Alright? Okay. Moving on to numbers 5 through 8. Now, on 5 through 8, we are going to decide whether the polyhedron is convex or non-convex. And then, if it's convex, does it look to be a regular polyhedron? Okay, so let's take a look at these. Now, students, on number 5, it's pretty obvious. It's non-convex. Remember, convex means there's no indentations, like if I were to draw a polygon like this. Well, it's kind of big, but you get the point. Okay, that would be non-convex or concave because there's an indentation right here, okay? Right here. Now, there's indentations on this polyhedron. Look, right here, goes down and back out, down and back out, down and back out, okay? There's all kinds of indentations, so no, this is not convex, okay? No, it's not regular, okay? It is not regular. It is non-convex. Number 6. Yes, this is a regular polygon. Okay. Excuse me. This is a convex polyhedron because there are no indentations, so it is convex. Now, is it regular or not? Yes, of course. I mean, we're just going by the naked eye. We're just kind of estimating what it looks like. First of all the faces have to be congruent. Okay? So in order to have a regular polyhedron, all of the faces have to be congruent polygons. Okay, and this is a cube, so all 6 faces are congruent. So yes, it is a regular polyhedron. Number 7. Well, guys, that's definitely convex. There's no indentations anywhere. And again, we're just going by the naked eye. Some of you might disagree, but the book says that all of these faces are congruent polygons. Now, I can see where some of you would think that's not true because the back one here looks a little bigger than the others, but I'm not going to argue with you on that. It's just an opinion question, and they say yes, it is a regular polyhedron. Okay. Number 8, that is definitely convex. Okay, there's no indentations anywhere. All right. However, all of the faces are not congruent. Now, these faces here might be congruent. The ones going up and down. Let me grab my pen real quick here. I mean, all of these side faces look very much to me like congruent polygons, and they probably are. Okay, but look at the bottom face. The bottom face is no more a triangle than a circle is a square. This is a 6-sided figure. Okay, so all of the faces are not congruent. So no, it is not regular. It is not. It is not regular. All right, moving on to numbers 9 through 12. The directions say to use Euler's formula to find the missing number. Okay, now the formula is, and hopefully you've not forgotten this in your notes, F plus V equals E plus 2. Okay, now let's copy that so we have it for the other 3 problems real quick here. Not that it's that difficult, but just so we have it. So, we're looking for the faces. So where the F is, I leave it F. That's what we're solving for. V would be 6. E would be 12. Well, guys, 12 plus 2 is 14. Bring your 6 over and make it a negative 6. And you're left with F equals 8. My, that's really simple, okay? Alright, number 10. Same formula, and here we go. Where the F is, I'll put a 5. Vertices are what we're looking for, so plus V. E is 9 plus 2. Well, guys, 9 plus 2 is 11. Bring the 5 over and make it a negative 5. 11 minus 5 is 6. So we have 6 vertices. Number 11. Same formula again. For the F, I'm going to substitute 20. For the V, I'm going to substitute 12. E is E. We're looking for how many edges the polyhedron has, plus 2. Well, guys, 20 plus 12 is 32. Now bring this 2 over and make it a negative 2. 32 minus 2 is 30. So E equals 30. Alright? Number 12. Where the F is, I'm going to leave it F. Where the V is, I'll substitute 10. Where the E is, I'll substitute 15. Well, students, 15 plus 2 is 17. Bring your 10 over and make it a negative 10. And F equals 7. F equals 7. Pretty simple, okay, students? Alright, moving on to numbers 13 through, let me look here, 13 through 16. State whether the solid is a polyhedron. Explain why or why not. Well, students, this is definitely a polyhedron. guys, look at every single face on this thing. It's a triangle, or it's a rectangle, or it's a square. Every single face is a polygon. So if all the faces are polygons, then we definitely have a polyhedron. So yes, this is a polyhedron. Alright, number 14. Yes, look. This is definitely a polyhedron. Students, if you look at all the faces, I mean, this is a pentagon, 5 sides. All of these are probably trapezoids, but either way, they're a 4-sided polygon, so a quadrilateral. But every single face is a polygon. Every single face. So yes, we have a polyhedron. No way. Look at this face right here. It's a circle. Look at the entire cone. The entire cone is rounded. No, this is not a polyhedron. Okay? All of the faces are not polygons. Number 16. Most definitely that's a polyhedron. Every single face is a rectangle, or kind of like a letter L-shaped figure. What? 1, 2, 3, 4, 5. 5 sides. 1, 2, 3, 4, 5, 6. So this is a 6-sided polygon right here. We have rectangles. Looks like a square right here. Every single face is a polygon. So yes, it's a polyhedron. Alright. Alright, now 17 through 22 are pretty interesting. Let's really think these through. Is a cube a regular polyhedron? First of all, is it a polyhedron? Yes, it is. Secondly, guys, of course a cube is regular. A cube, just by the definition of what a cube is, means all of the faces are congruent. Like a cube is 3 by 3 by 3. Width, length, height. Okay? So yes, any cube is going to be regular, and it's going to be a polyhedron. So that's definitely true. Number 18. A polyhedron can have exactly 3 faces. Absolutely not. There's no way. No, it can have 4 faces. You can have like a triangular base. And of course I can't draw it all, but picture like a triangular pyramid right here. It has a side to the left over here, a front side, a left side, and a bottom side. It's really a bad drawing. I'll tell you what, let's look back at number 7 real quick. Number 7 is a 4-sided polygon. 1, 2, 3, 4. Okay, so you can definitely have a 4-sided polyhedron, but no, you can never have a 3-sided polyhedron. It's impossible. You can't have a 3-sided solid. Well, yeah, Mr. Arrow, take a side here. It just can't be done, guys. You cannot have a 3-sided polyhedron, okay? You cannot have a 3-sided solid. Now, if you want to say a cylinder, I mean, I guess that would be a 3-sided solid. But boy, this entire round side right here really isn't a side at all. But for sure, no one can argue you cannot have a 3-sided polyhedron. It's not going to happen. This is not a polyhedron right here. You cannot have a 3-sided polyhedron. So false. Number 19, a polyhedron can have a circular face. Well, of course not. We've talked about that. Any polyhedron that has a circular face, or any solid that has a circular face, is not a polyhedron. That's false. Cannot happen. Number 20, a polygon can have exactly 4. A polyhedron can have exactly 4 faces. Well, yes, I just showed you one back at number 7, so true. Every convex polygon is regular. Well, of course not, guys. I mean, just think about it. No. In order for a convex polygon to be regular, every single face has to be congruent. Alright? False. You can have a convex polyhedron that's regular, and you can have one that's not regular. Alright? Number 20. Now, the 22. Now, this one's interesting here, guys. I'm not going to do any proofs. This was challenging for me. Now, the answer is true. Okay, just so you know, the answer is true. But here's the thing. Here's what I tried to do. I tried to draw a non-convex polyhedron. That was regular, and it couldn't be done. And I tried and tried, so yes, it is true. Every regular polyhedron is convex. Now notice I did not say that every convex polyhedron is regular. That would not be true. Remember way back in the first 9 weeks we learned that converses are not always true. So you cannot turn this around. You cannot say if you have a convex polyhedron it's regular. But you can say if you have a regular polyhedron it will be convex always. You can say that. That is true. Okay, 23 through 26, we're going to find the number of faces, vertices, and edges, okay? Let's start off with faces first. We have 1, 2, 3, 4 faces up top. Now, don't count this middle section. That's not a face. That's on the inside, okay? So no. Then we have 4 more faces down here. 1, 2, 3, 4. So we have 4 plus 4. We have 8 faces. Okay. Now vertices. We have 1, 2, 3, 4, 5, 6. So we have 6 vertices. Now remember the formula. If you take your faces plus your vertices, it'll always equal the edges plus 2. Or in other words, here's another quick way to look at it. If you know your faces and vertices, add them together and subtract 2. I'll show you. Put an 8 here, put a 6 here, add them together, 14 equals E plus 2. Now bring the 2 over, it becomes a negative 2, and look, 14 minus 2 is 12. So a fast way to do it is to take your faces and vertices, add them together, and simply divide, or simply subtract 2. Subtract 2, and there you go, the answer is 12. Okay, moving on to number 24. Let's first of all count the faces, okay? Now, it's hard to see how many of these rectangular slots or slides we have going back, but I've got an idea. If you'll notice, we can outline this thing. 1, 2, 3, 4, 5, 6, 7, 8. We have an 8-sided face right here. So that means I have 8 of these things going back, because for every side right here, I have a slot going back. So there's 1 there. There's 1 there. There's 1 there. It's really hard to see, okay? But what you end up with is 8 of these faces on the long side here. 8, okay? There's 8 of these right here. 8 of those. And the front has 1 face. And the back side over here has 1 face. So we have a total of 10 faces, alright? 10 faces. Okay, so let's count the vertices now, okay? The vertices. We have 8. 1, 2, 3, 4, 5, 6, 7, 8. Then 8 over here. 1, 2, 3, 4, 5, 6, 7, 8. So we have a total of 16 vertices, alright? Now, add those 2 together and subtract 2 from it, and you'll get 24, which has to be the edges. Alright, number 25. Well, let's count the faces, guys. This shouldn't be too difficult. There's 1. There's 2. There's 3. There's 4. And there's 5. So we know we have 5 faces. Now vertices we have 1, 2, 3, 4, 5. So we have 5 vertices, okay? Add those 2 together, subtract 2 from it, and we get 8. 8 edges. There are 8 edges. Alright, last but not least, number 26. Let's count the faces, okay? We have a big face up here. It's 1 big face, okay? 1. Then we have That's 4. That would be 5. That would be 6. And that would be 7. Okay, now you know what? I'm afraid I lost count here, guys. 1, 2, 3, 4, 5, 6. We count the top side of 7. Okay, that's right. Then the bottom side here would be 8. So we have a total of 8 faces. Now, for disease, well, let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I'm counting 12 vertices. Let's see if that's right. Okay, now to find the edges, add your faces and vertices together, and then subtract 2, and you'll get 18, which is the correct answer. Alright? Okay, students, I hope this homework help video has been a help to you. If you have any questions, don't hesitate to call or email.